Alright, good morning guys. Today we're going to talk about how to factor trinomials in the form of x squared plus bx plus c. Okay, really just a normal quadratic trinomial. Okay, we're going to look at a few examples and I want to show you how it relates to factoring by grouping. So last lesson we factored by grouping, and what you saw a lot in that case was problems that you came up with for factors that you had to deal with. Probably should have one of those examples written up, so I'll try to write one of those up now. Let me see if I can think of one really quick. 2, 4, okay, so here we go. So maybe a problem like this. X squared plus, let's say 4x plus, now I'm thinking bad, x plus 24. Let's say that. Okay, cool. So you saw a problem like this, and you had to factor it by grouping. And remember, factoring by grouping, what happened was there wasn't a common factor between all of these, or we checked for it at least. But then we saw that each group or pair had a factor that was common, and so we factored it out. Okay, so between these two, I can say my GCF is x. Between these two, I can say my GCF is 6. So I'm going to factor out x out of this group, and I got x plus 4. I'm going to factor out a positive 6 from this group, and I got x plus 4. And then we just noticed that, hey, these are both x plus 4s. Cool. Since they're the same, we can regroup this and say, okay, I have x plus 6, x plus 4s. Alright, and then we factored it. Alright, now it might seem like a coincidence once we get past how factoring by grouping. It might seem like a coincidence that this is even possible. What's the chances of you taking the GCF here and the GCF here and getting the same factor left? Okay, these problems were purposely set up this way so that they work out. And today we're going to talk about how to set up your own factoring by grouping problems, okay, with quadratic trinomials. All right, and so the way that I do this, I call it the AC method, mostly because of, I'll write an A here because we're not really dealing with A. A is always going to be 1 a day. But the AC method is finding two numbers that multiply to give you AC and add to give you B. Okay, and so in this case, I want to walk through how we can break it down so that we can get to a factor by grouping problem. We'll do a factor by grouping, and then I'll do a box method. Show you how to do box method, which will be, I think, easier for us to do in these problems. All right, so like I said, we're going to make a 4-term. We're going to make this 3-term polynomial into a 4-term polynomial. Not really. We're just going to split this middle term. Okay. But we have to make a way to strategically do it so factor by grouping works. And this is how you'll do that. You want to find two numbers that, when you multiply, will give you A times C. In this case, let's just say C today. Okay. Two numbers that, when you multiply, give you 7. And two numbers that, when you add, give you B. Okay, and that's B, the number in front of the variable, not B, the variable. Okay, so two numbers that when you add give you 8. Okay, so I'm going to think of two numbers that multiply to give me 7 and add to give me 8. Those two numbers come pretty quickly to me. I think 1 and 7. 1 and 7. Okay, should be the same for both of these. If it's not the same, then you got to think about it again. Okay, all right. Now what this does is it shows me how to split this middle term so that I can factor by grouping. Okay, and so I have b squared, and instead of writing 8, I'm going to write plus b, because that's the 1b, plus 7b, plus 7. Okay, so notice I took these terms, split the 8 here. Okay, so I split it. And now I have a factor by grouping problem. And I can do the same thing that we did yesterday. Take this group here, take the GCF, in this case it's B, and factor that out, and that gives me B plus 1. Take this group here, find the GCF, and that's 7, okay, positive 7, and that will leave me with B plus 1, okay? And so I know I did it right when I get the same factor, okay? At least that helps me think I did it right. And so now I'm going to reorganize this. I have B plus 7, B plus 1. And so I factored my trinomial, my quadratic trinomial, into 2 binomials. Group that for later so you see that it all goes together. Okay? Alright? And that's factoring by grouping. Alright, you can do that each time. If you'd like to, you can factor by grouping. Now the way that I prefer to do this is factoring using the box method. Okay, and you use pretty much the same strategy to get there, but box method again keeps it a little bit neater, a little bit easier to see that the order of these two don't necessarily matter. Sometimes when these two get switched up, people think they messed up in some way. But we'll walk through. It's pretty much the same steps. Okay. I want to. So we're going to do this by box method this time. Okay, so I'm going to draw this box. Okay, and before we were doing the box method to multiply, as I take a really long time to draw a simple box. Okay, but this time we're going to use the box method to factor. Notice that when we did factor by grouping, the first term and the last term stayed the same. B squared and 7 still stayed B squared and 7 when we started grouping. Okay, that's the same thing that's going to happen when we're factoring using the box method. The first term is going to be n squared. The last term is going to be negative 12. They'll stay the same. Alright, we have to find a way to split this middle term so that we can factor it. And it's going to be the same way that we did up here. We're going to find two numbers that multiply to give us C. In this case it's negative 12. And two numbers that add to give us B. In this case it's 4. So two numbers that multiply to give me negative 12 and add to give me 4. When you think about it, 1 and 12, no, doesn't work out. 6 and 2, 6 and 2. Okay, so they multiply to give me a negative number, so one number is going to be negative, one's going to be positive. They add to give me a positive number, so my bigger number is going to be 6. My smaller number is going to be negative 2. 6, negative 2. Okay, and notice that both these equations equal what we were looking for at the beginning of the problem. So here are my two values that I'm plugging into these boxes. 6n, negative 2n. And so now I am going to factor, kind of do the box method backwards. Okay, I'm going to go through each row and each column and I'm going to find the GCF. GCF between these two is n. GCF between these two, say, is 6. GCF between these two, both negative, I'll say negative 2. And GCF between these two, n. Okay? And so then you should just double check, make sure that when you go through that each of these boxes come out to be what was already in the box. So n times negative 2 is negative 2n. N times n is n squared. 6 times n is 6n. Okay, got it. So here are my factors. I have n plus 6 and n minus 2. And that's it. Okay, so either method works out. It's really the same method. Again, I like the box method because it's kind of condensed. um, still feels a little easier to check over your work. We'll go through a couple more examples here, and then that'll be the end. So let's do one more, or another one here. We have a squared minus a minus 90. Okay, so I'm trying to find two numbers that multiply to give me negative 90 and add to give me, in this case it's negative 1. Do my box. Okay, so that's a squared here, negative 90 here, they stay. I had to find the two values that fit here. I think add to give me negative 1, so negative 10, positive 9. Negative 10, positive 9. Okay, and so I'll put those values here, negative 10a, positive 9a. Doesn't matter which box I put those in. I could do either order, works out. Then I go through and get my GCFs. So a, these are both negative. I'll say negative 10, 9, a. Make sure I know the difference between my 9s and a's. Okay, and so go through, make sure each of the boxes multiply each of the factors multiply to give me what's in the box. Okay, and so they do, and that's my answer. A minus 10, a plus 9. Alright. Let's go one more example. So last example, if you have space on the same page, that's fine. Last example, we have 2n squared plus 6n minus 108. Okay. Now I want to throw this example in there because I know we said we were dealing with only problems where a is 1 today. But it's important that even though we are not necessarily focusing on greatest common factor, that we have our eyes open for it. Okay, the previous problems, a was 1, and so we knew that we didn't have a greatest common factor in the values. The last term didn't have a variable, so we knew we didn't have a greatest common factor in the variables. In this case, we have 2, 6, 108. Okay, all these values are even numbers. Okay, in this case, we have a GCF. The GCF is 2. We want to make sure that we identify and factor out any GCFs before we try to do box method or factor by grouping each time. Okay, because without doing that, we won't get an accurate answer. Okay, so I noticed that there's a 2 as a GCF, factored it out, and now we're back to where we started from, being able to do this. Okay, if you want to pause it and try it on your own, do that. If you want to follow along, do that. Two numbers that multiply give me negative 54. Two numbers that add to give me 3. Alright. Just a quick, I guess since this is the last one, this is a good time to talk about how you can find these numbers. Okay? Alright, shouldn't have drawn that line. Alright. I always start with trying to find the two numbers that multiply first because there's less possibilities of whole numbers that multiply to give you a number than whole numbers that add to give you a number. And so I want to find two numbers that multiply to give me negative 54. If I'm having trouble figuring that out, what I would recommend that you do is just write all the combinations that you can find to multiply to get that number. So 1, 54, 2, 27, 3, 18, all right? 4 doesn't go into it, 5 doesn't go into it, 6 and 9. Okay, my next one would be 9 and 6. Okay. Okay, you can do that on a calculator if you need to and you're having trouble. You can just go through and do 54 divided by 2, 227. 54 divided by 3, 318. 54 divided by 4, doesn't work, don't use it. 54 divided by 5, doesn't work, don't use it. Okay, so if you're really stuck with finding a pair of numbers, you can do that. Alright. So now I need to find two numbers that multiply to give me negative 54 and add to give me 3. I want to show you how to use these signs as a tip to find what your number is going to be. Alright, they multiply to give you a negative number. So what does that mean? That means that your signs are opposite. You have different signs. You have a positive and a negative. That's the only way you can multiply to give a negative number. And they add to give you a positive number. So that means the biggest number is positive. So my signs are different. The biggest number is positive. I'm going to make sure my smallest number each time is negative. And see which one adds to give me 3. Okay, this adds to give me this adds to give me positive 53. This gives me 25. This gives me 15. This gives me 3. So 6, negative 6, and 9 are my options. Okay, now I have my box. N squared, negative 54, negative 6n, 9n, factor, 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 factor. Okay, make sure it all works out. And here are our answers. N minus 6, N plus 9 from the box, but don't forget that we factored out the GCF at the beginning. It needs to be in our final answer. Alright, we'll work on this more and get really good at it. See ya tomorrow.